The derivative function always gives us the slope or the gradient of a function. When f-x is equal to 0, that implies that the slope is horizontal, and these horizontal slopes can only be found at the maxima or the minima of a curve. And therefore, if we draw a tangent at the maximum, or if we draw a tangent at the minimum, this is therefore our maximum here, and our minimum is here. And you can see why these points are called stationary, because in a way you can stand on those tangents. There is a flat line to stand on, but you can also have a horizontal tangent on a curve which is not a maxima or a minima. On a curve like this, I can also draw a horizontal line which will go through this particular curve, point of curvature. And I can also draw a curve in the other direction. So as you can see, we can also draw the horizontal tangents through these curves. So we can also call them stationary. But unlike the first two, which are just called turning points, whereas these two curves have a stationary point of inflection. And at the stationary point of inflection, the horizontal line goes through the curve. And you'll also notice that the gradient of the tangent has the same sign on either side of the stationary inflection. Now, what they have all in common is that all of them can be found making the derivative equal to 0. That means that the tangent or the slope has to be 0 at these points. And the sign diagram at these points would look like, at the point, maximum point, where our stickman is standing, the left-hand side would be positive because the slope here is a positive slope, and the right-hand side would be negative because the left-hand side is a negative slope. And similarly, for our minimum point, the slope is negative on the left-hand side, and it goes up on the right-hand side. Now, for our stationary points of inflection, the slope for this curve would be positive, positive. So we can write positive on this side and positive, whereas on the other curve, it's negative, negative. And this is how you can tell the difference between turning points and stationary points of inflection. The turning points will have different signs on either side, whereas the stationary points of inflection will have the same sign on both sides. Now, there is another turning point on a curve, which is a point of inflection, but it is not stationary because the tangent on that point is not horizontal. This will occur mainly between two stationary points. There could be a maxima and a minima, or there could have been a maxima and stationary point of inflection. If you examine the blue line here, you'll note that there is a point on that function where the curvature, the shape of the curvature changes. So somewhere around the middle here. The reason that it changes because the slope changes. Now, the slope of the blue line is negative, definitely, but it changes its steepness. The slope at the very top is 0, and the slope at the very bottom here is also 0. But as it progresses, the slope is negative, and then its negative is increased, and then its steepness is increased and increased and increased and increased until it comes to a particular point where the steepness is the greatest, negative, and then it starts to decrease its negative steepness again. So that's why I'm drawing those little lines shorter and shorter and shorter to show that this is getting less steep. And as you can see, it is negative throughout this line, but its steepness changes, and at this particular point the curvature changes. Can you see that at this point the gradient intersects the curve? In other words, it goes through the curve. This point is called the non-stationary inflection point, and this happens at the junction where the slope decreases and the slope increases here. In other words, between the concave part of this and the convex part with this. Now, it may seem to you that when you look at the derivative, the zeros of the derivative correspond to the two local extremes of this function, and the inflection point may seem to look as if it is indeed the midpoint between those two maxima and minima. But in reality, this only happens for cubic polynomials. In higher polynomials of higher degree, that skews this symmetry and it prevents the inflection point to lie in the middle. I would like to say a little bit more about non-stationary points of inflection. I'll do this in the next video, so please be kind and subscribe to my videos. It really helps me, and also if you could put thumbs up, that makes the algorithm go a lot further and it shows my videos to a far greater audience.